Okay, so the video for refraction that I promised, just to clarify a few things. So today we said refraction was the bending of light, X that goes from one medium to another. So let's call this side up here medium 1, and this side down here medium 2. And if you look in your notes, it actually says that refraction is the bending of light as it goes from one medium to another obliquely. And I didn't talk about that today because we were running out of time. But the word obliquely means at any other angle other than 90 degrees. If light happens to come in at an angle of 90 degrees with the surface, in other words, coming in perpendicular and hitting the surface, then it won't bend. So it has to come in at some angle other than 90 degrees with the surface. Pretend that's a straight line. Okay? So here's my incident ray, and here's my angle of incidence. Okay? So if it comes in perpendicular to the surface, it won't bend, but any other angle it will. Then we talk about it bending towards or away from the normal. So if it wasn't going to bend, it would come straight through. If it bends, then it's either going to bend what we would say would be towards the normal, so that it bends closer to the normal than what it would be going if it was going straight through, or away from the normal, which means it would be up here, meaning it's further from the normal than what it would be if it went straight through. Okay? Now, whether it bends towards or away is going to depend on the difference in the densities of the two media, plural for medium. So let's say, we'll draw our surface again, and let's say that up here, medium 1 is something like air. And let's say medium 2 is something like water. It means in this particular case it's going from less dense to more dense. When it goes from less dense to more dense, instead of going straight through, it's going to bend towards the normal. So we say less dense to more dense towards. So MLT, it bends towards the normal, which means the angle of refraction is smaller than the angle of incidence. Okay? So that's one scenario. The other scenario would be if it was going from more dense, so medium 1, maybe this time is water, and it's going into something that's less dense, so medium 2 might be the air. So here's the incident ray coming in, here's theta 1, and instead of going straight through, when it's going from more dense to less dense, it bends away from the normal, so that the theta 2 is going to be bigger than theta 1. So we say when it goes from more to less dense, it bends away. Okay? And it will come in handy for you if you can remember when it bends towards or when it bends away. And you'll notice I wrote down MLA down here because I think you've all heard of MLA. When we're talking about writing a term paper, for example, MLA is a way of referencing things. If you're talking about government, like in the province of New Brunswick, MLA is your member of Legislative Assembly. So M in this case here, instead of referencing or government, stands for more to less away. If it's less to more, then it must be towards. So I just write the letters because sometimes it helps people to remember which way. All right? So then if we look at why does it bend toward when it's going from less to more, it bends toward because the part of the wave that enters the water first, or the second medium first, slows down more. So it gets bent back. And I drew that picture today on the board, like when we were walking on the beach and some of you entered the water first. So that part lags behind. And so instead of being up here like this, they're going to be back. And so that's bending towards the normal. And the reverse will be true when it's going into a less dense medium. Okay? And so then we get Snell's law. N1 sine theta 1 equals N2 sine theta 2. So if I were to tell you something like, let's say we're doing this scenario right here, since I'm right beside it. Let's say it's going from water into air, and let's say that the angle of incidence is like 40 degrees. Okay? So, and I will ask you, so if theta 1 is 40 degrees, what must theta 2 be? What must the angle of refraction be if it's going from water to air? So you want to solve for theta 2. So rearrange Snell's law. The N1 sine theta 1 equals N2 sine theta 2. Rearrange it so you can solve for theta 2. Okay? So divide both sides by N2. So sine theta 2 will equal N1 sine theta 1 over N2. Now in the chart, either in the package of notes I gave you or in your textbook in that chart that I showed you there today, you can find theta 1 and theta 2. Theta 1 is water, and when you look it up, it's 1.333. Okay, no units because n's are just a ratio or a comparison of the speed of sound. Remember this equation we saw today, or excuse me, the speed of light in a vacuum divided by the speed in any other medium. It's going to be meters per second over meters per second, and they're going to cancel no units. So index of refraction doesn't have any units. This sine theta 1 will be sine of 40, and then you look up, shoot, I didn't pick a very good angle. Then you look up air, and going into air, it'll be 1.000, I forget, I need to find the chart. It's really close to 1. Oh, chart's on the back, not forward. 0.29. Okay, so make this 0.29. Now, I know even as I write this that this might be a problem. So you take your calculator then, you do 1.333 times the sine of 40 divided by 1.00029. I forgot to put the 1 in. 1.00029, and you get sine theta 2 equals 0.856587, etc. Then you do the second function, sine. So you do inverse sine, and you find out that theta 2 is equal to 58.936 degrees, which is bigger than theta 1. And it's bigger because if you look at our picture up here, we had figured out that it would move away, and that would make theta 2 bigger. Okay, so this is how you use Snell's law. I could also give you theta 1 and theta 2, and I could ask you to solve for one of the ends. Sometimes even, I'll give you theta 1 and theta 2 and ask you to solve for one of the ends, and then I'll say, what must this material be? And then you take that in, and you go to the chart, and you look up which one's closest to it. Let's suppose that I say theta 1 is, let's say theta 1 is, I don't know, 30 degrees this time. And let's say we're going from, should move it so you can actually see what I'm writing. Let's say this time we're going from air into, we'll do water again. So we'll just turn the thing around. So this time we're starting in air and going to water.